Alright guys, this is number 3 on your chapter 13 homework. So the question says, consider the following scenario to understand the relationship between marginal and average value. Suppose Kevin is a professional baseball player and his game log for free throw can be summarized in the following table. So the first game, it says right here, so the first game, the game result is 8 out of 10, so total is 8 out of 10, and then his game throw percentage is 80%, and the average free throw percentage is also 80%. Now, for the second game, he did 6 out of 10, so that should be 60%. So just use a calculator, use the number divided by the percentage. Where was I? Okay, so just use the 6 divided by 10, that will give you 60%, okay? And then next, asking for your average free throw percentage, you're going to use a 14 divided by 20, so that will be 70. And then on the third game, he did 1 out of 5. Whoa, that's horrible. That's like a Shaquille O'Neal performance. So 1 out of 5, that's 20%. And then the total is 15 out of 25. So that will be, what, 60%? And then the fourth game is 3 out of 5. That's another 60%. So 3 out of 5 is 0.6. And then 18 out of 30. Let me get my calculator. Alright, so 18 divided by 30, that's gonna be, I think 60%. I could be wrong. Oh, it is 60%. Man, I'm pretty good at this. So 60%. And then for last game, it's 8 out of 10. That's 80% right there. And then the average will be 26 out of 40. That's 65%. Okay, so that's easy. Next, we're going to plot the points. So on the following graph, use the orange points to plot Kevin's free throw percentage for each game individually, and then use the green points to plot his overall free throw percentage for after each game. Alright, so first game, 80%, so we're going to use our orange symbol. So first game is 80%. Second game, 60, and then 20, 60, 80. So 60, 20, 60, and 80. Oh, it's symmetric. And then for the average, it's going to be 80, 70, 60. So 80, 70, 60, and then after that it's going to be 60 and 65. So 60 and 65. Okay, that's that. Alright, so next part of the question says, you can think of the result in any one game as being Kevin's marginal free throw percentage. Based on your previous answer, you can deduce that when Kevin's marginal free throw percentage is below the average must do what? Now, if you look at this pattern over here on the graph, every game, so let's take game 2. See for how on game 2 the orange line, the one game percentage, when it's below the green line, when it's below average, the average is always going down. But see how after this fourth game, especially on the fifth game, when the one game percentage is higher, then the average is going up. So every time your marginal is below average, the average must decrease or falling. And then vice versa, if any time your marginal is above average, the average will be rising. Okay. And then last part question says, you can now apply the analysis to production cost for a U-shaped average total cost curve. When the marginal cost curve is below the average total cost curve, the average total cost must be falling because it's lower. Also, when the marginal cost curve is above average total cost, the average total cost must be rising. Therefore, the marginal cost curve intersect the total cost curve. Okay, see at this point, when they intersect, that's the turning point. Okay, so let's look at what our question choice is. So when it's at turning point, now this turning point, so before this, when the marginal cost curve is below the average total cost, the average total cost is increasing. But once the marginal total cost curve is above your average total cost, the ATC is increasing. So this intersection is representing the lowest point of your ATC. So this will be the minimum. All right, so let's grid it now. We're good, we are good. No, I'm sorry, I'm good. falling. All right, so that we did good. So that's the answer for number 3 on your chapter 13 homework. Have any question, let me know, and good luck.